Thanks, August. So, welcome everyone to the ProdText Ergonomics on the Cloud webinar. My name is Ricky Cartwright. I'm the head of technology at ProdText, and I'm here to talk to you today about the toolset and the applications we use at ProdText to achieve benefits to our business from ergonomic analysis. So, let's crack on with the webinar here. First of all, a bit of background about ProdText. We're based in the UK, Sweden, and Norway, and we have three main activities in the UK. The first is 3DEXPERIENCE Delmia digital manufacturing. We use Dassault Systèmes' advanced toolset to generate digital manufacturing solutions for our customers, incorporating production planning, virtual commissioning, digital twins, work instructions, discrete event simulation, and ergonomics. The second activity is robotics, where we create and simulate kinematic devices. We use offline programming and we produce development work on new automated solutions for the market. The third is reconfigurable tooling. So this is taking sustainable, modular, and reusable tooling solutions for industry. We use our own patented technology to produce these solutions, and we produce full turnkey solutions. So how does all of this relate to ergonomics? Well, in all of those three main activities, we find that ergonomics analysis is a key factor in working as efficiently as we can and getting the maximum benefits in those activities. So I'm going to talk you through a little bit about how we do that now. So for example, a key feature of manufacturing and production is people. So any digital manufacturing work has to consider the people and how they're going to be impacted by and interact with the solutions we're developing, simulating, and validating digitally. In robotics, we also require people to be involved at some point in the process, whether that's setting up the cell, performing maintenance, or working alongside the robot in a collaborative scenario. Understanding when and how people are going to interact with the robots and how they're going to do it safely is essential to the process. And then in reconfigurable tooling, our fixturing solutions are built by us. We go onto customer sites and assemble them ourselves most of the time. So it's really important that we've assessed, the ergonomics properly. As I don't want to be lifting up a beam that's too heavy for me and doing my back end. I don't want any of my staff to be doing that. And of course, the end users for those fixtures are people. They're going to be using them to manufacture or assemble the product. So understanding the key parameters that make it as user-friendly for them as possible, like what height it should be at, reach access, how they're going to be able to interact with the fixture at various different points. It's vital to understand and assess that as early as possible in the design process. So onto the tool set and how we use it. The foundation of our solutions is Dassault Systèmes' 3DEXPERIENCE platform. And this is the successor to CATIA V5, and it's from the same company that developed SolidWorks. It's a platform that contains hundreds of apps within it, and it has software functions tailored for every element of an engineering company, from design through to stress, analysis, procurement, logistics, and marketing. Customers can buy as many or as few apps as they like, so you can invest in 3DEXPERIENCE and use it across the whole business, or buy just the ergonomics apps and use it for a small dedicated team. It's a software which brings together all forms of data, CAD, KPIs, Excel spreadsheets, automation, logistics, processes, your work instruction documents. All of that information and data is brought together into a single platform. It removes silos, and it's about bringing people from across the business together so they're all using the same interface and the same platform. It provides a catalog of applications to enable users to design, inform, collaborate, and simulate. And essentially, the backbone of the platform is connecting the latest data to the right people when they need it. And it's something that sounds very easy, but it's actually quite difficult to do. So in 3DEXPERIENCE, I mentioned there's loads of different apps. So I'm going to run through some of the different ergonomic tools in the platform. that you can use and that we use. The first of these is Work Safety Engineer. It's a dedicated tool for ergonomists and human factors specialists to allow them to virtually simulate and assess the manufacturing scenarios or user experiences during the development process. There's a huge number of features in this tool that allows you to do everything from checking someone can reach a tool or a switch to understand the impact of using exoskeleton suits. With this tool, you can capture and reuse basic skills or complex tasks. EWK lets you define a sequence of postures such as kneeling and sitting. These sequences can be saved in a library for application to a mannequin, simplifying task definition. Similarly, users can save more complex tasks as templates in a library and reuse them in other contexts. An important benefit of ergonomics is to reduce the risk of injury. Musculoskeletal conditions are the highest contributor to global disability, and they're responsible for 2% of all gross national cost products in industry. So using the advanced tools in 3DEXPERIENCE Delmia, designers can avert injuries in the workplace through early identification of potential ergonomics problems. We also have push, pull, and carry analysis, as well as lift and lowering analysis. So these are two separate tools. You can use the push, pull, and carry analysis tool, which incorporates the Snook and Sorello equations. It takes distance and population samples and uses those as inputs to provide a maximum acceptable carrying weight. The pushing and pulling force can then be compared to what's considered a safe force for the activity. There's also the lifting and lowering analysis, and that utilizes the NIOSH 1981 to 1991, as well as the Snook and Sorello guidelines. It takes duration, frequency, the lifting posture, start and finish, and coupling conditions, and it uses those as inputs to provide recommended and maximum weights for the objects that user can lift. And then once you've got these results, you can export them into a text or a HTML format. You can easily, with this tool, switch target populations crucially without having to update the tasks you've created. So for example, you can teach a mannequin from one population, say a European 80 percentile male. You can take that mannequin, you can teach it a series of motion postures to create the task you want them to do. It could be, lifting a tool, walking over to the component in the fixture, and then using the tool to drill some holes. And then after you've taught the mannequin those postures, you can complete the analysis on that mannequin to see how ergonomically how they perform. But then you want to see how that works for different mannequins in your database, right? So you can basically switch users to a different population, such as an Asian 50 percentile female, and then you can basically run that analysis again and get the results without having to update any of the taught tasks. And then the final thing I'm going to dive into in a little bit of detail on this slide is task sequencing for multiple humans, robots, and devices. So a human task's made of activities that describe a worker's assignment. The tool provides functions for sequencing activities, editing the sequence, and assigning tasks to let users evaluate the way humans interact in a manufacturing environment. Users can sequence and simulate the tasks of each individually programmed human, robot, and device to validate the synchronized behavior of the work cell. And then there's loads of other things you can do with this tool. You can capture and reuse ergonomic standards as well as the motions. You can build libraries of common actions. You can take into account time management from task level to motion elements. Look at biomechanics analysis. You can analyze and understand the mannequin's vision and assess their field of view. The list goes on and on. The tool uses the ruler analysis standards to assess the ergonomic performance. So if you don't know, ruler stands for Rapid Upper Limb Assessment, and it's a tool that's used to identify ergonomic risk factors. associated with upper limb musculo-skeletal disorders. So that can include things like pain in joints, muscles, ligaments, nerves, tendons. The way the tool works basically is that it measures the amount of risk among workers due to constant exposure to postures and muscle activities that have been shown to contribute to strain injuries. And it basically requires an evaluation of scores between 1 and 7 for each of these. So a lower score means that no actions required, and a higher score means an immediate actions required, and you need to stop that activity straight away. There's loads of other analysis options in the tool, so you can analyze reach envelopes for individual workers. You can look at sweat volumes of a worker's movements during doing a task. You can create Gantt charts of worker activities, and then there's a really in-depth tool called biomechanics single action analysis, and that measures the biomechanical data on a worker in a given pose. It takes the current mannequin posture and calculates output information based on that. So it could be things like the lumbar spinal loads. So, taking things like abdominal force, abdominal pressure, and body movements. And then the forces and moments on the mannequin joints are all those outputs are all incorporated in the model to give you some very in-depth results of how the actions are affecting all of those different features. Another really great tool we've got is the Ergonomics Mannequin Editor. So this allows you to create custom populations. The tool comes with, as standard, the tool comes with like a wide variety of populations that you can use. So that includes full percentile adjustment for male and female body types over 7 different nationalities. You've got Canada, France, Japan, Korea, USA, Germany, and India. But you may have a very specific population that you want to simulate outside of that. It's not covered by those standard populations. So it could be a different region, it could be a specific population for your own company that you have, or it could be an individual person that you want to replicate in the tool. And this app gives you the function to create a mannequin to represent those individual populations or people. So it basically gives you the ability to adjust the specific body measurements of a mannequin to suit your needs. And you've got very in-depth features in there. You can adjust every element of the mannequin to get exactly the replication of the person that you want in there. And next I'm going to move on and I'm going to show an example of how you can work with the tool and what you can do with it in detail. So this is about a 2 or 3 minute video, and it's just looking at how a simulation can be performed on a mannequin to check the position of a control stick in an aircraft cockpit. So essentially what we're doing here, we're putting like a human interaction point on the control stick here. So you can see there's a load of different options for with your hand for how you might want to interact with that. You can, touch your finger on it. You could touch your foot on it. You could point at it. You could, grasp with just your forefingers, or you can grasp with your whole hand in different size of grips. So you select the type of grasp you want, and it gives you some geometry and an axis to represent that. And then you can edit how that interacts with the specific feature you've selected. So we've selected the control stick part here. It automatically puts it on the axis at the center of the part, and then you can adjust that as you see fit. So you could move it, you could rotate it, you can change the diameter of the grasping point, you can change the length of the cylinder, and to get exactly how you want aligned with the geometry. And then it's basically fixed on the geometry in that point there. So if you move that control stick, the human interaction point will move with it now. So now any mannequin you select can snap their hand onto that human interaction point. But we don't want to just do one motion here. We want to chain a couple of motions together to create this specific human interaction. So we're naming the human interaction here, and then we're going to set up the initial conditions for the interaction. So we selected the mannequin, and what you can do here is you can select how much you want the mannequin to be able to move to interact with it. So instead of selecting the full body, we're selecting certain segments here because we don't want their legs to be able to move. So we only want their upper body, we want their legs to stay in that seated position. But you could do things with this, like you could say, actually, I want to simulate a mannequin that's strapped into the pit and can't move their torso. So you could restrict the chest and the upper torso as well and just have their arms and shoulders able to move. For this instance, we're going to allow the torso to move. And next, what we're going to do here is create another interaction here. And now what we want, we've got them grasping and holding the control stick, but what we also want them to be able to do is to look at the control stick, because generally if you're going to grab a tool, you'll look at it first before you do that. So we've created a look at option there and selected the control stick. Now we're activating that human interaction, and we're going to apply that to the mannequin here. So we've created it, we've activated it, and we're just going to click one button now, and we'll apply that. And you can see the mannequin snapped into position, holding the control stick, looking at it, and it's automatically optimized him to be in the best position he can be without moving his legs at all. But so we've done that once. We can analyze the results, see how ergonomically good or bad it is, move the control stick and get it into the optimum position for him. But we also want to look at different populations here. So we literally just right click on the mannequin, change the parameters to an American woman in the 5th percentile, and you can see that's updated our mannequin. But now, because the mannequin's body sizes are all different, they're no longer holding onto their control stick. And as you'll see in a minute, when we turn on the line of sight for the mannequin, you can see quite clearly they're not looking at the control stick anymore. So we don't need to go through and create that whole interaction again. It's already been set up, and you saw there where there was literally just one click to run that interaction again with the new mannequin, and the hand and the line of sight snaps back to where we want them to be. And obviously we can chain even more interactions together or less. We can run that on as many different populations as we want really quickly and get those results, which is, I think, is a really good example of how you can optimize your time with this tool by setting something up once and rerunning it over again. Moving on now, I want to talk about a slightly different tool in the toolkit here. So everything I've been looking at previously has been aimed a bit more at really in-depth use cases for users that want to really dig into the tool set that we've got here and spend a lot of time performing detailed analysis. But this tool here, Ergonomics Workplace Designer, is aimed much more at, say, a mechanical engineer, a production planner, or a designer, rather than those specialist ergonomists. And the reason for this is because we want everyone in the business that's making decisions which impact ergonomics to have the tools available to them to understand the impact of those decisions. So whilst the tools I've shown previously are fantastic for ergonomists and human factor specialists, they're probably too complex and in-depth for a production planner who really just wants to get on with the thing they're good at and the thing that they've got all their skills in, and they don't want to learn a whole new tool set just to understand if the platform they're building is at the right height or not. So they want a tool set for them that allows them to very quickly get an idea of whether the ergonomics are good without having to spend a lot of time in training on it. And that's where Ergonomics Workplace Designer comes in. It's got great features. Actually, let's start the video here, that'd be useful. It's got great features like one-click mannequin position, which allow users to get an understanding of whether a scenario will be suitable for all of the users. So this means that designers can quickly identify the problem areas in their process and highlight these for a dedicated ergonomist to focus their time and attention using the specialist tools we described previously. And it works really well, this tool. You'll see on the screen in a second. What you kind of get is you select what it is you want to look at, create a scenario with 1 or 2 clicks, and then you get this little toolbar at the top with a traffic light logo for your different populations of mannequin, maximum and minimum percentiles for male and female, and they've got a traffic light system on them just to tell you, is this ergonomically sound? Green, yes, it's fine, it works well. Amber, there may be a problem. Red, definite problem. You need to, either change this or promote it to your ergonomic specialist for further analysis. And that really is all the information that the designer wants. They don't want to know the exact details of the ruler analysis. They don't want to know, specifically what the various differences are in detail between those populations. Is it good or is it bad? Does it work? Yes or no? And that really, and now as well as kind of saving the designers time by not having to spend a lot of time on using these tools. It saves the ergonomists a lot of time because they only have to look at the real problem areas that have already been highlighted by this tool. So instead of having to assess 20 or 30 different ergonomic scenarios, they may only just spend all their time looking at the 2 or 3 problem areas and be able to really put the right amount of time into resolving those. So I think it can be a real game changer for ergonomists, this tool. And then one more tool that I wanted to run through here that we've personally found to be a massive benefit when assessing ergonomics throughout the design and production lifecycle is the use of VR. So 3DEXPERIENCE has virtual reality capabilities built into it, and that means that for any design data, manufacturing scenarios, or robotic simulations that are in the 3DEXPERIENCE environment, you can simply put on a headset, click one button, and then you're reviewing them in VR at 1-to-1 scale. And we found this to be a really great tool to change your perspective and think differently when assessing ergonomics, simply just by being present within the environment rather than viewing it from above at a different scale. With 3DEXPERIENCE, you can also work collaboratively in the VR environment, so multiple people can enter the same VR simulation from remote locations and interact with each other when reviewing the scenario. And whilst these features are of huge benefit, I think for ergonomists, the real benefits start to come when you're able to interact with tools and parts in VR and track and analyze the user's movements. And I'm delighted to announce that Protex are now partners with 2 really exciting companies whose technology enable these features. Xsense and Haption Motion have developed some incredibly impressive tools which integrate with 3DEXPERIENCE, and this basically allows users to sync their physical movements with a mannequin in the VR simulation. So this means that you can create clash indicators with the 3D geometry, you can interact with tools and record the motion of the mannequin for review and assessment at a later date. Effectively, it allows you to assess the real performance of a worker in a production process while it's still in the design phase. And then taking that to the next level, you can incorporate the Xsense Awinda motion tracking suit that allows you to track and analyze a user's motion to a really high accuracy. It's also possible to put this suit on users in a production environment and track and record and analyze their performance in the real production scenario. Now, that data is obviously invaluable as you can assess and modify the user's performance from a data-driven perspective when they're carrying out that task in real life. But what it also allows you to do is create a catalog of users' real motions, which you can then import back into 3DEXPERIENCE and use when assessing your future production scenarios. So I think those tools are really exciting and really enable you to take a different perspective and a different approach to ergonomics with the use of VR. So I've gone through a lot of different tools today and applications for them, but the question is, what does all of this actually mean for your business? So the tools that I've presented enable modern engineering companies to implement a holistic ergonomics thread within their business that will transform ergonomics from a task that's performed when a problem is discovered or a box to be ticked during the development process to a consistent tool which informs and benefits the key decisions made during the development lifecycle. And I really believe that if used correctly, these tools will not only benefit the end users by reducing the risk of injury or increasing the final user experience, but it will benefit all elements of the business by enabling designers to make key decisions about products much earlier in the process. It will improve delivery times by simulating scenarios to find the right solution first time, and it will reduce costs by focusing specialist time on the key areas and eliminating costly rework. So I really think this is a game changer. And hopefully the next question that you're all asking is, sounds great, how can I try out these tools? How can I understand how they're going to benefit my business and get, first-hand look at them? Well, we have a promotion available at the moment, which allows you to try 3DEXPERIENCE on the cloud for a minimal fee. what you can basically do, anyone who doesn't have, any company that doesn't have any 3D experience capability at the moment, you can take a 3-month low-cost trial, essentially, where you can try as many of the different applications and tool sets in there as you want for just €330 per user for the 3 months. And you get to create your own environment, bring in your own data, use the tools, perform ergonomic simulations, see the results you get for it, train your team, all of that you can do. And then at the end of it, if you don't like it, if you think actually this is no better than what we've already got, fine. There's no commitment to carry on afterwards. But crucially, if it is working for you, if it is delivering you the benefit, you've got that first-hand data and understanding, and you've done that training and whatnot without making a huge investment, and then you can build that business case because you know exactly what the benefits are going to be and how it's going to benefit your business. So that's a really great promotion, and if you're interested in that, please get in touch with us. We can talk through the details of it and understand your use cases and help you understand what you might need and what might be beneficial for you. So that's it for the webinar today. Thank you very much for all of your time. I hope it was informative. I've got mine and August's contact details on the screen there for you. And if there's any questions or answers, we'd love to hear them.